Assalamualaikum warahmatullahi wabarakatuh. My name is Mohamad Saiful bin Ali. My metric number is B0918104002, and I'm from BMMM, and I want to present my bachelor degree project, PSM1. So my title is Investigation of Mechanical and Physical Properties of a Natural Fiber Reinforced Composite using a Taguchi method for a bagas. First of all, I want to thank to my supervisor, which is Encik Muhammad bin Fadhilah bin Zainudin, and I also want to thank to my panel, my first and second panel, which is Dr.Najiyah Safwa and Encik Azrin for watching my video. So, introduction. As we know, bagas is from sugarcane, which is a raw material that has been manufactured to collect the ethanol and the sugar, and the remaining fibrous residue is we call as a bagas. And then we also know that natural fiber become one of the further increasing the using in the technology of the composite. There is also many benefit using the natural fibers, such as its renewability. It is renewable. It's a low density, which is this is light, and then it's environmentally friendly and biodegradable, and then it's flexible. So we move to the next slide, which is for the problem statement. There is three problem statement, which is the first one. There is a limitation on the producing the composite based on the chemical material, because it is not good for the nature or the ecosystem, and then it's hard to find. And then the second one is natural material nowadays at the entire world is excessively waste, and then this is damaging the ecosystem. And then the third one is there is still no detailed experiment that were performed to analyze the best way to make a good biocomposite. So we move to the next slide, which is for the objective. The first, there is also three objectives. The first objective is to study about the physical properties of the sugarcane bagas reinforced of the fiber composite. And then the second one is also same, to study the mechanical properties of the sugarcane bagas reinforced of the fiber composite. And then the third one is to find the optimum factor between the different level in producing the high strength of the biocomposite by using the Taguchi method. So we move to the next slide, which is for the scope. For the scope, there is three scope, which is the first one is we will do testing the bagas fiber by using the tensile test at the ASTM E23 standard for the tensile test. For the physical properties, which is we use the biodegradability test at ASTM D695 118. And then the last one is we use the Taguchi method on the based on the result for the tensile test and the biodegradability test to find the optimum factor and level to make a good biocomposite. So we move to the methodology. So as we can see, this is the flowchart of the methodology. So we start with the A, and then we do the sample preparation. So sample preparation in here is the bagas fiber, and then we running a test, which is we have the two tests, which is the tensile test and the biodegradability test. And then after we running the test, we must collect the data, and then from the data collection we put it into the Minitab to do the Taguchi method. And then from the Minitab by doing the Taguchi method, we can know which factor at which level can define the greatest strength of the our new natural biocomposite. And then after we do the Taguchi method, we do the test, and we do the data collection, we analyze, discuss, and we conclude it in our project. So and then in the end of the project lah, and then we move to the next slide, which is the sample preparation. So first thing first, we need to do the bagas preparation. So to do the bagas preparation, first thing first, we must have the sugar cane. So from the sugar cane, we must to extract it to remove the ethanol, sugar, and the liquid from the sugar cane, and then we dry it for a day or 2 days to make the bagas is dry. And then after the drying process, we do the removing residue to make the bagas is more clean. And then after we removing the residue, we crushing it to make the bagas is smaller and fine. And then it's the completed process to make the crushed bagas with a fine and smaller bagas. So we after the day 1, we move to the day 2, which is we add the additive composition, which is we have the 4 composition, which is we have 3 composition. We have additive composition, which is we have a bagas at the first one, and then we have the PVA glue, we have the cassava starch, and then we have the size of fiber. So we mix it to make the new our biocomposite. And then the next day, at the day 3, we draw our sample preparation. So as you guys can see, this is the sample drawing, which is we do the dog bone shape, so that it's easy to do a tensile test. And then at the day 3, to make the dog bone shape, so what we do is we preheat our new biocomposite that has been mixed, and then we mold it and we compress it, and then we design it design our dog bone shape. So after we get our sample preparation, the sample preparation is ready to running a test. So we move to the next slide, which is this is the software and equipment of testing that I'm using for this project. So which is we have the Minitab, we have a tensile machine, and we have the biodegradability equipment. So for the Minitab, so we do the Taguchi there to get the greatest strength of our new biocomposite. And then we do the for the tensile machine, we do the tensile test to know the strength of our new biocomposite. And then we do the biodegradability test, which is we use a soil, we do a biodegrade test for maybe for 2 or 3 weeks to get the result for the physical properties of our new biocomposite. And then and the tensile machine for the mechanical properties of our new biocomposite. And then from there we do the Taguchi method. And then the Taguchi method, this is the preliminary finding or the expected result, what we need from what we has been shown from at the Minitab while we doing the Taguchi method. So this is the result. We don't get the main result because there is still we don't get the response from the tensile test and response from the biodegradability test, which is we don't have the value of the tensile test for all the 8 experiment for the tensile test and the biodegradability test. So that's all from me. Thank you to Dr. Najiyah Safwa and Encik Azrin for watching my video. That's all from me. Thank you.